So, dear students, once again welcome. Let us talk about how to control a manipulator. How to control a manipulator. So, what is manipulator? As per, if you see the book of Professor S.K. Saha, Professor S.K. Saha, it is the mechanical structure of the robot. So in general, we say manipulator, sometimes we say robot. But manipulator includes the mechanical structure of the robot. And the robot means the robot should have its own base, like this is the base of the robot, and uh, this is the joint 1, joint 2, and it is the manipulator. Okay, so this is what this is the base of the robot, and these are what this one and this one, these are links. Okay, and the links may be either rigid or flexible. So generally for the study, for the analysis, we consider the rigid one. Why? Because it is much easier than flexible. But if actual robot system is flexible, then there will be no option. Okay. And what is this? This is what? This is the and effector of the robot. Okay. So what is the mechanical structure? So other than base, if you consider, and even not the and effector. So this arm, this links actually from here to here, these are the arms. You can see here the total link 1 arm, which include all the links, like a link 1 plus link 2 for this case. So it is arm. Okay. And what about the end effector is part of robots? So remember, end effector, this one is not part of the robot, not part of the robot. Okay, and how the joints are actuated. So here, suppose joint theta 1 is here, and here theta 2 is here. So how joints are actuated? So either due to motors, or some gear, pinion, or some mechanical devices, or some hydraulic system or pneumatic system. Okay, which provides motion to the robot. Robot means the end effector. Okay, so now our question is, the robot will behave the same what we expect. Like suppose this is the okay, and suppose their robot has to perform the multiple weldings, like arc weldings. If you visit the Tata Motors, then you will find the number of robots are acting. Okay, so suppose robot is deployed to do welding, and for that accurate positioning are required. And suppose robot has to means has to perform the task accurately, and some profile is given. Okay, this is just for example, like suppose some profile is given, like this is the S profile, and whether this example is fitted for this or not. Okay, but here this is the S, and suppose it is the required trajectory. Okay, and is it necessary the robot will behave the same what we expect? No, it is not necessary. And suppose robot behaves like this. Okay, so it is the actual trajectory. Okay, so what will be the problem due to this error? And what is error? So error means that is the reference velocity minus the actual velocity. Okay, and suppose for x direction, the x dot, this is the reference one, and x dot here the actual one, and this required trajectory is what means this is the reference velocity. Okay, so these errors, so with this error can the robot can locate the task or the object at the required place, required location? So no, our answer is no. So what is required then? Then controller is required. That's why here the control of a manipulator is required. What is the role of that? The error is either amplified or the magnitude is reduced. Okay? Either as per requirement amplified means what? The error here, sorry for this, error is corrected here. Better to say here, error is corrected. Error is corrected here. Is corrected. But with the help of what? With the help of feedback control system. Okay, so feedback control system, what is this? So it matches the error. This error is measured by the sensor and by the comparator. It is compared and then it is modified. The error is modified like मीन्स रोबोट को बहुत ज़्यादा टॉर्क सप्लाई हो रहा है जितना रिक्वायर्ड नहीं है, तो क्या करना पड़ेगा? देन टॉर्क सप्लाइड शुड बी रिड्यूस्ड, मीन्स मोटर को मीन्स पैरामीटर्स को एडजस्ट करना पड़ेगा सो दैट द रिक्वायर्ड टॉर्क कैन बी जनरेटेड. नहीं भाई बहुत ज़्यादा टॉर्क जनरेट हो रहा है, दैट मच इज नॉट रिक्वायर्ड. ठीक है, तो वहाँ पे क्या करना पड़ेगा? द मीन्स रिड्यूस करना पड़ेगा. ठीक है, एंड समटाइम्स सपोज द रिक्वायर्ड टॉर्क is very less, and because of this error increases. So what we have to do now? We have to tell the robot, oh, you work hard and supply the more torque so that this error can be minimized. This error can be minimized. Okay. Okay. So then the block diagram of the feedback system through the feedback control system we will come to know from this lecture. And so feedback control systems, okay, can be divided into open feedback and closed feedback. Okay, and let us this we understand with the help of block diagram. Okay, so this one, and suppose there is a controller unit. Okay, controller unit and driver means motor, and then or you can say driver to the motor. Driver to the motor. And then output. Okay, once again this. So control system means suppose a PID, PI or PD. Okay, and control system, so क्या करेगा, this will supply uh, the whatever the torque or forces required to the robot through the driver and the manipulator. Then what we get, output. Okay, so this output is not sensed and controlled. जो भी output मिल रहा है, okay, there is a no possibilities to correct it. Like a water tank में valve, you suppose there is a no valve in water tank, so water will be overflowing. But if there will be valve, like, so this comes under the closed feedback system. And the same thing like the controller unit, then driver, then motor, then the output, okay, but this output is sensed. This output is sensed through the sensor and given back through the feedback system. Feedback system, it is given back. The direction will be like that, and it is given back to the controller. Okay, so this comes under the closed feedback system. There is a feedback system which controls the error, the signals, whether the signal has to modify, whether it has to increase or decrease. Signal means whatever the torque signal or force signal. So this is the feedback control system. And the in more better way we can understand the closed feedback system with the help of the block diagram. Suppose there's a comparator, then error, then here controller, then the process, you can say the robot, then next output, then this output goes to the sensor, okay, then sensor to feedback system, or you can say element, and feedback element, and it is feedback to what, to the controller, sorry, comparator. कंपैरेटर बोल सकते हैं या कंट्रोलर बोल सकते हैं, अल्टीमेटली इट गोज टू कंट्रोलर. ठीक है, ये अब ज़्यादा डिटेल्ड वे में है. ओके, सो कंपैरेटर एंड दिस इज व्हाट, दिस इज द फीडबैक, and here the set point means the reference trajectory. This is what the reference input in terms of trajectory, and this output is what, the actual trajectory. Okay, so in this way, now with the help of this, what I have given example like the S curve, this one. So this is what? Once again, this is the set point, but here better to write reference or the desired or required trajectory. Okay, so whether we are getting the same trajectory or not. So suppose I'm getting the same trajectory here over the reference trajectory. So you can see here both are coinciding, desired and actual. This is the actual trajectory. Okay, so this is only possible with the help of feedback system. Okay, the which one feedback system? The closed feedback system. Without this the robot cannot behave properly. ठीक है कि आप उसको बोलेंगे यहाँ पे वेल्डिंग कर दो तो वेल्डिंग तो कर देगा, बट विथ सम errors which cannot be accepted. That's why controllers are required. ठीक है, so and not only this, suppose that they check the S curve. This is what the S curve, or you can say the B spline curve. So error is suppose minimizing, then we will get the accurate or more accurate trajectory.